So, hello guys. Sorry for the delay. Myself Sudeep, and I'm thrilled to welcome you all to day 2 of the Machine Learning Workshop 2.0, organized by Society of Automotive Engineers, Collegiate Club of NIT Durgapur. Are you guys ready for the exciting journey into the world of machine learning? We had a great start yesterday, okay? And today we'll be diving even deeper. But before we get into hands-on live coding session that I'm sure we are all looking forward to, we'll begin with a quick recapitulation of the points we covered on day 1. So, sit tight and make sure you're ready to get your hands dirty in code today as we build a model together. So without further ado, let's kick off the recapitulation of the previous day's session. Yesterday, we began by exploring the fundamentals of machine learning. We discussed the different types of ML, supervised learning, unsupervised learning, reinforcement learning. We also introduced the concept of datasets and how they are split into test, train, and validation, and how machine learning models make predictions. We talked about the challenges of overfitting, underfitting, and how hyperparameters can influence a model's performance. We covered one of the most commonly used algorithms, which is linear regression. We worked through how it works and how it is used for predicting continuous values. And next we transitioned to the world of neural networks, also called deep learning. We explored the structure of neuron, also called perceptrons, the role of weights and biases, and how backpropagation is used to update the parameters of the network. To help illustrate this, we even used a practical example of a music recommender system. Then we moved on to CNN, which is the key part that we'll be using in building our model in the live coding session today, which will definitely be the most exciting part for guys, as you all will venture into the trenches with us by getting your hands dirty and code yourselves. We have covered several important topics in CNN, like how to handle images that have a grid-like topology, how CNNs are different from regular artificial neural networks, and the special role CNNs play in image classification tasks. Then we discussed about the convolution operation and how it's used to process image data. Then we moved on to the concept of strides and pooling and why they are crucial for reducing the computational complexity of a CNN. Lastly, we looked at the typical structure of a CNN and how the trainable parameters involved are trained using backpropagation. To make things clearer, I also demonstrated the convolution and pooling operation using examples from deeplizard.com. You can also view it yourself from deeplizard.com. So, for our focus on today will be Python programming for machine learning. Since machine learning models are built and trained using Python, we'll start today's session refreshing some important Python concepts that we'll need. We'll cover basic Python syntax like variables, data types, operators, and input and output. We already taught you guys this part, but I'm just going to recapitulate that for you guys, those who have missed it. Just give a thumbs up if you guys are ready to start, okay? Give a thumbs up in the chat. Yeah, I can see the responses. So all guys are active. Yeah. Very good. So I'll be starting in just a minute. So I'll be recapitulating about you the basic concepts of Python that we discussed yesterday. So first thing is variable. A variable is name given to a memory location in a program. It's actually used for storing any data at any location. The basic rules for Python variables are the name must start with a letter or underscore character. The Python variable name cannot start with a number. The Python variable name can only contain alphanumeric characters and underscores, and the names are case sensitive. And next will be variable assignment. We actually use the equal to operator to assign any value to a variable. Next are the types of operators. There are arithmetic operators, plus, minus, divide, and percent modulo and power functions. Then there are relational and comparational operators. Then there are logical operators, and then there are relational operators. Then we talked about comments. Comments are actually just a line that are ignored when we are typing any code during the execution of the program. For a single line comment, we use the hashtag, and for multi-line comment, we use actually 3 double inverted commas. Then we use the important thing that are data types, which is integer is for used for assigning minus, positive, and zero signs. Float is used for decimal digits. Boolean are used for true and false statements. Strings are used for any variable that use ABs, like for example ABC we want to store, so you store it in string, and none where we don't want to store anything. Next is input and output function. So like input function is input function takes the input from the user, and the output function actually is the gives output to us. Okay, so this is a recapitulate of the Python part yesterday. So now I will like to hand over to Vinayak for teaching you the part about loops. So please stay tuned. Okay. So hello guys. So hello guys. Let us start with the loops part right now. There are two types of loops. Okay. One is while loop and another one is for loop. But let us start with why are loops used. Loops are used to repeat the instructions. Like you have an instruction, like you want to print some statement for 5 times, or you want to check whether the condition is whether the condition is satisfied or not. For that number of times you want to print a statement, or do some work, or do addition and multiplication, whatever work you are doing. You put that under the loop and and make the condition. In Python, a while loop is used to execute a block of statement repeatedly until a given condition is satisfied. When the condition becomes false, the line immediately after the loop is executed. Now we can see the syntax of while loop. Here we can see the while loop is taken, and under that while loop we write under bracket we write the condition, and after that the work we need to do, that work is done. Now we are seeing some examples. In this example we are watching count is equal to 0. We are assigning a variable which is taken as 0, while count is less than 3. Whenever the value of the count is less than 3, the next statement is being printed. Okay. Now this part is on. Here the count is the iterator, and the loop is also the iterator. Now let us see the application of using the else statement with while loop in Python. The else clause is only executed when your while condition becomes false. If you break out of the loop, or if an exception is raised, it won't be executed. The syntax of while loop with else statement is shown in this figure. While condition and as well as. Let us see one example of else statement in a while loop. The same example is taken. Count is taken as 0. While again the while condition is taken where the count is less than 3. In each and every iteration, count is increased by a value of 1. See, count is equal to count plus 1. That means for count 0, it will be turned into 1. Now the new value of the count is 1. Now the print statement has been the print statement, that is good morning, is being printed. Again the same iteration goes on. When the count is value 1, it is always we know that 1 is less than 3, and say again the same way. In the same way, the good morning statement is again printed. Now when the value becomes 4, now it can't become it is not less than 3. Hence we can't run the while statement. Now we will print the good evening, what is written in the else part. Okay, that is a good evening. Now let us come up with the for loop. For loops are used for sequential traversals. For loop syntax is given. For example, let us say n is equal to 4 for I in range of 0, n.
let us know what is range function first. Okay, the range the range function returns a sequence of numbers in a given range. The most common use of it is iterate sequence on a sequence of numbers using Python loops. Syntax of range is the range function is taken under that bracket. The first argument which is taken, that is the starting of the value, and the second argument is the stop value, and the third argument is the stepwise. Are you guys getting it? Please give a thumbs up if you guys are getting it, or any doubts, please write in the comment box. Please raise your hand if you find any doubts in this. Or should I proceed? Then give me a thumbs up, please. Thank you. Now let us come to the example part. Okay. I have made you understand the range function. What is the range function? For in this example, I have assigned a variable where n is equal to 4 for I in range of 0, n. For I means the range function, what it does is it is taking all the values from 0 to n. What is n? What is n? N is 4, and we know what is it taking? 0, 1, 2, 3. Not n. It is not taking the n. It is taking n minus 1. So it will take 0, 1, 2, 3. These 3. And for each and every I means for each I is taken as the symbol as a variable for each and every element in the valve in the range of 0, 0, 1, 2. And in the next statement, in the next line, it is printing all the print I values. Okay. Now let us come up with the next example. See, for I in range of 5. What does it mean? That it will print 5 values. Now let us run this statement and see what we are getting. So here we are finding some error because of we are not taking this. Now let us take an example of printing all the natural numbers. Okay. For I in range of 5 to 20, we are taking all the numbers, or we are taking the range 5, 20 because we are taking all the numbers in like 5, 4, 5, 6, 7, 8, 9 up to 19, and we are printing all the numbers like 5, 6, 7, 8, 9, 10, and up to 19 only because we are taking the ending statement as 20. See, here it is. We are taking printing all the numbers from 5 to 10. Now let's see what is how can we do the range part. Now let us see how can you raise the end. How we are using the step part. In the range function, see here 0, 10, 2. 0, 10, 2. What does it mean? That we are printing from 0 to 2 and it takes an interval of 10. It is taken an interval of 2. Now let us print what we are getting it. See 0, 2, 4, 6, 8. That's all with the loops part. It is pretty easy part. I think you guys don't have any doubt. If you have any doubt, please feel free to use the chat box as well as you can also raise your hand. So no doubts I guess. The next part of the if else part will be taught by Priya. Go to you.
So guys, you have already learned about the basics of Python, which was taught by my friends. So let's dig deeper into the Python sections. So we all have things pre-planned in our life, like if it rains, we'll take umbrella. If not, we won't. For this situation, Python provides us with conditional statements. So let's know what are conditional statements. It is used for taking decisions, and there Python provides us with different types of conditional statements. The simplest one is if statement. It is used when there is only one condition. So let's see the syntax of if statement. In if statement, only here, as you can see, if is a keyword, and then within the parentheses, conditions are given. And an extended version of if statement is if and else statement. Here, if and else statement is used when there are two conditions given. And in this, else keyword is given, and if first condition is not true, then the else condition is executed. So as you have already learned that logical state conditions which are in mathematics are supported by Python, like equals to, not equals to, less than, greater than, and so on. So let's know about if else statement with an example. So first we will know about if. So if we want to know if a number is odd or even, you know how I hope you all know how to check if a number is even or not. First, let us give a number n is equals to 10. So for checking this, if a number n is even or not, we will give the condition. I hope you are getting this. Then we'll print even. Wait a minute, we will get the output soon. Yes, the number is even, as we can see that. But what happens if it is an odd number? For this, we will write up the else condition, else print odd. So let's see the output of this code. Yes, the output is odd. So let's see another example. Here, I'm taking an age and then showing if the user is eligible to vote or not. So let's see the output. Wait a second, guys. So I am entering an age 70 and we get the output as not eligible to vote. Then elif is also there in conditional statement which is provided by Python. In this, if there are more than two conditions given, then we use elif. Like here, if the first condition is true, if block is executed, and if the first condition is false, then the second elif condition is executed. And if the both conditions are false, then third condition is executed. And if all the other condition 1, 2, and 3 condition are false, then else is executed. Let's look into it by an example. Like here, we are taking two numbers, A and B, and checking if the numbers are equal. And if the numbers are equal, it is printing both numbers are equal. And if A is greater, it prints first number is greater than second. And if A is smaller, it prints second number is greater than first. Else, it is invalid. Let's see how it works. Let's give the first number as 18 and the second number as 92. We all know the output, like second number is greater than the first number. So if you guys have any doubt up till now, you can just raise your hand. If not, then give a thumbs up. Okay. let's move forward. So sometimes it is required to break a statement if the condition is true. So for this, break is given, break keyword is used. So let's see how it works. Here I hope you all know how the range and for works as taught earlier. So here we are taking num whose numbers change from 0 to 20. So here we are only printing the numbers which are less than 15. Like here the condition is given, num is greater than 15, then it breaks the loop. So let's see the output. So yes, it prints all the numbers that are smaller than or equal to 15. And then Python also provides us with continue, which skips the loop if the condition is true. So let's see the example here. We have taken the same statement, first statement, but the condition is different. Here we are skipping all the odd numbers. Here, as you can see, if the number is odd, we have used the continue keyword, which skips this part, and else part is printing the number. So let's see the output. So here, as we can see, all the even numbers within 20 are printed. Next is nested if-else statement. In this, one if condition is given within the other if condition. Like here, you can see the syntax. If the condition 1 is true, then the condition 2 is executed, and so on. We can give multiple if condition within a if condition, but if the first condition is false, then the else condition is executed. Let's see an example for this. Like here, we are taking a number n and then checking with if the number is odd. And if the number is odd, we are checking if the number is divisible by 5. If the number is divisible by 5, we are printing number is odd and divisible by 5. Else the number is odd but not divisible by 5. This is one block within the if condition, and the other part of if is else condition, which states that the number is even. So let's type a number 729 and see the output. So yeah, you can see the number is odd but not divisible by 5. I hope it is clear. If not, you can raise your hand. Okay, it's a thumbs up, so you all are. So, as I was talking about functions. Functions are used when a condition is to be used upon a number of data. So, there are two types of functions, user-defined and predefined. Predefined functions are already within the Python libraries like print. As we have already used the print function many a time, so I'll talk about it later in deeper. And first we'll know about user-defined function. User-defined function are defined by def keyword. The syntax is given here, so let's know how it works. First, def keyword is given, then the function name is provided. Within the parenthesis, parameters are given, like we can give any value, and then this is how the function is declared. Then the function definition is there, like what are the conditions which we want to perform in this, and then return keyword returns the value which we want to get, and then the function is called. For function calling, we use the function name which is already provided there, and then the values are given. So let's see a simple example for this. Here I have defined a function fun1, which is taking name and then printing the statement my name is and the name of the user which is provided. So function calling is done by fun1. In parenthesis, we are giving the name which we want to print, and the output is this. My name is Nitin. So let's look to another example, that is this function is is returning the product of two numbers, A and B. Here A and B are the parameters which are given, and then here we are taking the first value A and the second value B, and we are calling the function product. So let's see. First number if we give as 4 and the second number as 8. So we know the product of 4 and 8 is 32. So sometimes it is required to print multiple values. So we can do this also. For this we have to separate the values by comma in return. So let's see the result. So in result we are getting 20 and 30, which is the value of A and B respectively, separated by space. So now let's talk about predefined functions. Today we will know about generator, lambda and map and filter functions. So first we have generator function. Generator function generates a series of value at a time, and these values are not stored in the memory as a whole. So let's see what is done in the example. Here we have defined a function table, which is in which the value of I is from 1 to n minus 1. As you all know how the range function works. So this is yielding the values of I, multiple values of I, and then we are taking a number n. And then we have called the function table here. In table we have passed the value of n as 11. That means the value of I will change from 1 to 10. Then we are printing n. That will be given, like here I have given 4 and it is printing n into j. The first value of j will be equals to I, that is 1. So it will print 4 into 1, then it will print 4 into 2, that is the next value, and then the last value of I will be 10, which will be equals to j, and it will print n, and that is 4 into 10, that is 40. So this is how the output is. Then we move on next to lambda function. Lambda functions don't have any name, they are single line functions. So here A is a lambda function is provided here, where n and p are the arguments, like n and p, and this is the syntax how we give. Here the lambda function is returning the product of two numbers, and we have given the value of n as 18 and p as 4. So the product of 18 and 4 is 72, and it is returning the 72 value. Then we move on to map and filter function. Map function returns a set of data according to the condition provided. Like here, we have a num list. About list, we will know further. Here, we are taking a list num in the list, each element is performed by square, and then here a set list is the output, on which the square is performed. Like the square of 1 is 1, square of 2 is 4, and 3 is 4, and respectively we are getting the square of 4 and 5 by using the square function. The syntax of map function is given here, like map is written, and within the parenthesis function name is given, and then the data structure, that is the num, is given. Next we move on to filter function. Filter function filters a list of data according to the given condition. Like here we have provided a list of 10, 15, 20, 25, 30 and 50, and in here we are printing all the even numbers from the list by defining a user defined function even. So we get the output as 10, 20, 30 and 50. If you guys have any query, then raise your hands. If not, you can just give a thumbs up. Okay, so let's move forward. Next we come to string. You were already introduced to string, so let's know more about string. String is a data type in Python that represents a sequence of characters. It is immutable, which means that once a string is created, it cannot be changed. And the syntax of string is that it is written within a single quote or double quotes. So indexing in string. we have two indexes, positive that is from the left and negative that starts from the right. So if we talk about the positive indexing, the first character, like here we have taken this example as string. So the first character is given the index 0, second is given 1 and so on. As we can see, the number of character in this is 6. So the last character is given the number index 5. And if we talk about the negative indexing, the last index starts from negative 1 and the first one is given the index negative 6. String slicing. Slicing means that we are accessing that part of a string only. For getting the sliced string, we use the syntax string name, start index is given and end index is given. So let's know about it by an example. Like S is equals to string. And if, as you can see, the indexing. So if I want to print up to the index 3, so I have to write it like print S 0 to 4. Why 4? Because like in range, the slicing also works like this. Like if you take 4, then it will print -1 up to -1. So the output will be STRI, this first 4. So this is how it works. So there is another example. So anyone who would like to answer? Okay, let's know the output. The output is NIT_D. As you can see, the first 0th index is N, first is I, T, and then the 5th index is U. So it will print up to only DO. So if you want, what if we want to reverse this indexing thing? We use this syntax. Like the first will be R from the like negative indexing, -1, -2, -3, and these 3 will be printed. -1 means in the negative direction. So we next come up to deleting. Like if you want to delete a character from the string, it is not possible, as we know that it is immutable. So let's see what are the functions which are performed on the string, that is length, find, count, upper and lower, swap case and capitalize. We will know about each one by one. We have taken a string ST_NIT Durgapur. So let's print if you want to print the length of the string, which is 12. Like you can see 1, 2, 3, space is 4, 5, 6, 7, 8, 9, 10, 11, 12. So length is 12. And if you want find function, will find the pool, which is on the index 9 from the forward direction. So it will print the first occurrence of this and find that where is this substring. And count function will count the occurrence of U in this string. As you can see, U has occurred 2 times. So let's see. Yeah, it occurred 2 times. Upper will convert this whole string into uppercase. And lower will convert this whole string into lowercase. And capitalize is capitalizing the first word only. The first character only is capitalized and rest is not. Swap case is changing if the word, if some characters are in uppercase, it will convert them into lowercase and vice versa. If any one of you is having any kind of query in the string part, you can raise your hand, or if not, then give a thumbs up. Okay, let's move forward. The next is string. Next is list. Lists are very important. So let's know how are lists built and what are they. Lists are the built-in data structures in Python. It is a collection of data, like we have already used it in an example. List, like it stores values within a square brackets. As you can see, we have used it earlier. These are ordered, mutable, and they do allow duplicate values. So indexing of list is similar to that of string. Like first element is given the index 0, and the last one, like if there are n elements, then the last one is given n minus 1 index. So, and the range of indices, let's see how it works. Like here I have given, like if you want to print the sum from the list, if you want to print sum of the elements, then we can use the this syntax. Like here is an example, like this list contains 9 elements, so the last index is 8. We only want to print like skipping some values, like there is step value 2. It means that we are skipping an element and moving to next one. So it will print first element, that is 0th index, then skip this, print this, skip this, print this. As the index is 7, so it means it will only take up to 77. So if this is printed, skip, printed, skip, so it will be printed. So let's see if this is the output. Yes, 22, 44 and 66 are omitted. You know that I already told you our lists are ordered and mutable. So let's skip and list. Lists are mutable, so we can change list. Let's see how list elements are changed. Like here a list 1 is given 1, 2, 3, 4, 5 elements, and if you want the index 2 element to be 8, like 3 will be replaced by 8. So we can use this. So let's see if there is any change. Yes, third element is 3 is changed by 8. Like slicing in string, we can also use slicing in list. So 2 to 5 index, that means 3 to 5 are printed. So as we change, so we got 8, 4 and 5 up to index. What if we want to change this? So we can give 2 to 5 elements will be replaced by 9, 7 and 0, and new list will be created and the numbers are replaced here, and if we print the list, a new list is there, 1, 2, 9, 7 and 0. Let's see the function that are performed on list. Len, you have already seen about it. Insert, append, extend, sort, pop, remove, clear and del. Let's see about them. As you can see, there are 8 elements, so it is printing 8 as the length of the list. And then we have insert. Insert takes 2 parameters. First one is index, then next one is the new item which you want to insert. So we here I am replacing the third index element with 0. So let's see. 4 is inserting a new element 0 at the index 3. So the third index element is 0. Now I want to add a new element at the end of the list. So we'll use append, and I am adding 23 element at the end of the list. So let's see the output. Yes, 23 is added to the end of the list. And next is extend. It is extend is used when there are multiple values to be added. Let's see the output. 11, 9 and 80 are added to the list. Sort is used for arranging a list in ascending order. So let's see. Yes, it is in ascending order. Let's see if you want to reverse this. Yeah. For reversing, we use reverse is equals to 2. So here it is reversed. Pop is used when we want to remove an element, like we want to remove this. So third index is removed here. And next is remove. Remove is removing the element 80. So 80 is omitted here. And next is clear. Clear will empty the list, and an empty list is printed, and delete will delete the whole list, and error will be showing if we print this. If you have any query, you can raise your hands. Okay, let's skip to the next part. Tuples are similar to list, but they are immutable, and they are written within a parenthesis. So indexing is similar to as list, so we'll skip that part. Like immutable, we can see like we change an element in list, so we should try like if we can change or not. Let's see if we can change the first index 1 as 0. It is showing error. That means it is tuple is immutable. For checking if an element is present in a tuple, we can use in keyword. This is showing true for this part. If we want to update a tuple, we have to convert it into a list. Like here, I have converted this tuple into a list. Then we have changed the element. Then I have reconverted the tuple into list and then printed the list. Function as list tuple is immutable. Very few functions can be performed on this, like length, which is printing the length, and sort will sort the list according to ascending order. And for reversing it, we have to use it like this. It is printing in descending order, and delete will do the same work as earlier. So let's move on to sets. Sets is also a type of data structure, but it is unordered, immutable, unindexed, and do not allow duplicate values, and written within a curly braces. The properties of sets are different from the list and tuple, as they are having no index, so we cannot access the elements of sets by indexing, and it is unordered, so no index is given, and immutable, so very few changes can be made in this. So let's see the functions that can be performed here. So we can see the length of a set. Here the length of the set is 7. If we want to add an element, we can use this syntax. Like I want to add 28. As it is unindexed, 28 will be added randomly. So we can say like it is added at the last, but it can be random. If you want to add multiple values, we can use update, which will add multiple values. Like here, it is giving them the random places, and it can be within the parentheses. We can give any type of data. Like here, I have given sets. Here tuple. So it doesn't make any change. It will take all the values, and remove will remove the element from this set, like 2 is removed from the set. And if 87, like 87 is not in the sets, so it will produce an error. A discard will do the same thing, but it is different. Let's see how. Like 10 is present in the list and it will delete 10. But what if an element is not present? It won't show any error, but simply just print that sets only. Pop will randomly remove any element from the sets. Like here, 20, like an element is omitted. Yeah, first element is omitted. Clear will do the same work, and del will do the same work as earlier. There are some basic differences between list and tuple. Are like tuple is immutable, but list is mutable. Like you can see the differences. Like tuple is within the parentheses and it is within the square brackets. Not much changes can be performed in tuple, but many functions can be performed on list. So this is where I'll end the part. If you are having any query, you can ask questions by raising hands. If not, give a thumbs up. Okay.
Is also one of the unique data structure present in Python. First of all, what do you know about data structure? Do you know anything about data structures? If you know, I need to show me your reactions. Yeah, data structures mainly stores the data
now you are learning C in your first semester, right? In C, arrays, mostly you heard about arrays, which is a data structure, stores the data, and we can also manipulate the data using the data structures. In the similar way, in Python, we have dictionaries as a unique data type in which we can store the data and also manipulate the data. And up to now, you have learned about lists, sets, and tuple, in which you are dealt with only single data. You store a single data and you operate on a single data. But dictionaries in Python has a unique feature that we can have key value pairs. We can operate the data in the pairs. Dictionary in Python is collection of key values used to store data values like a map, which unlike the other data types hold a single value. Yeah, that's true. But in list, you have access to the single element at a time. But in dictionaries, we can access the data with the help of key values. For every value, there exists a unique key value. So that with the help of that key value, we can access the key value. In Python, both lists and dictionaries are commonly used data structures, but they serve different purposes and have distinct characteristics. Here is the breakdown of the key difference between the list and dictionaries. Now I am going to teach you little differences between the list and the dictionaries in Python data structures. And I already taught you that a list is an ordered collection of items. In list, the elements will be ordered. The input order we give will be stored in the same order, but it does not happen in the dictionaries. And list maintains the order of elements based on their index. That's true, guys. For suppose in list, you enter an element and its index will map to 0. And you enter the other element, it goes to 1. And you enter the other element, it goes to 2. The order in which we give the input will be stored in the similar manner. But in dictionaries, it does not happen in the similar way. The order will change definitely. And a dictionary is an unordered collection of key value pairs. Each key in the dictionary is a unique and maps to a specific value. Yeah, in dictionary, it is stored in key value pairs. For every distinct value of key, we have distinct value of value. With the help of key only, we can access that particular value. And I will show you how we can write code on order. List maintains the order of elements. I already told you, list maintains the order in which the first element added will have 0 index and the second element added will have 1 and so on. But in dictionaries, we do not guarantee the specific order of key value pairs. Yeah, the order which we give as input may not store in the similar way as list. So I will run a code. See this session 1, which is a dictionary. How can you identify a dictionary? See this curly braces and along with a unique key value. See this key value. Instead of key 1, you can also write only single 1 and then John. Key 2 maps to Jacob. Key 3 maps to Jack. We gave input that a key 1 that maps to John. Key 2 that maps to the Jacob. Key 3 that maps to the Jack. We gave this input and let's see what output we get. Print session 1. We are printing total the dictionary. Let's see what we get as output. Yeah, key 1 equal to John, key 2 Jacob, and key 3 Jack. You will get much more and you will better understand in this code. See this, watch this carefully. Key 1 maps to John, key 2 maps to Jacob, key 3 maps to Jack. Now I want to print which value corresponds to the key 2. So print session 1 square brackets key 2. Let's see what will be the output. See, here we are getting output as Jacob. The Jacob, it's a value and the corresponding key it maps, it has holds is key 2. So when we want to access Jacob, we used the value key 2, session 1 of key 2. In the similar way, if you want to print John, you code like this: print session 1 square brackets key 1. Then you get John because key 1 is mapped to John, and key 2, and if you want to get Jack, then code print session 1 of square brackets key 3, because key 3 is mapped to Jack. So if you want to access Jack, you must use only key 3. So in the similar way, I will teach you third code. Yeah. If you want to know how many pairs are present in the dictionary, so you simply write print len, which is a standard keyword, len of session 1. Here we get output as 3 because we are having 3 pairs, key 1, key 2, key 3. That's it for it, guys. Now Divya will take over.
Hello guys, in Python you have learned about its basics, different data types, how to create functions in it, and different data structures. Now let's learn about an important topic, which is CSV file importing. First of all, what is a CSV file and why do we use this format for importing a file? Well, CSV file stands for comma separated values. It's a plain text format that is widely used to store tabular data, and each line represents a row of data. The values of a line are separated by commas, comma separated values. So where is CSV files used and why they are used preferably rather than other formats of the file? Well, this format is preferred because it is very compatible with different software applications and they provide a very simpler way to transfer data in structured format or in tabular form. It is also preferred to store massive amount of data sets, and it provides a lightweight manner to store data and manage them. So you have learned what are CSV files and why are we using it. So let's work on CSV files. CSV file, generally in your devices, default format of the file is text format. So you have to import the CSV format from your CSV module or CSV library. So you will be using the import keyword to import the CSV models. And after CSV files, you will be learning about different libraries and you have to import them. So first let's see. CSV file stores the data and they are separated by commas. It stores massive amount of data you will be seeing. Now let's open a CSV file. This is the code for opening a CSV file. Import CSV, and you have to specify the path the file you are opening to analyze or read. Here R signifies that you are opening the file in read mode. That means you are only going to read the file. You cannot edit it. This is the syntax for opening a CSV file. With when path, the path is the variable which is storing the path of the file you are going to open. And R here signifies the read mode. As file, you are opening the file with a name file. You can give any name. You can do it in Cola with me now. This is a variable, another variable where I am storing the CSV format of the file. And I am using, and this is the function. The reader function is used for reading any format of a file. Here we are using the CSV format. File is the name of the file given as the variable. Now, for line in read. Before you have learned about the for loop. Prior to this, you used a for loop when you knew the number of iterations, and you used it for ranges or some counter variable like I or j in a range of numbers. It may have intervals or not. Here, similarly, we are using the for loop for each line in the file, and we are printing all the lines. See, I told you, comma separated values, and each line represents a row of data, and each line are printed. Now, let me give you another example. See, here I have again imported the CSV file. I have copied the path of a CSV file and I have opened it. Let's see the output. See, these are the actual CSV files. See, how much data are there. You can't even count it. This is the actual size of the files you will be handling while doing ML projects. You know, you will be dealing with massive amount of data sets. you will be dealing with massive amount of data sets, and these are the size regularly used for your projects. So now let me hide the output and explain you how I got this path. In Colab, you have many sample CSV files. These are the sample CSV files. I used this path. You can use this path or any file path. Now, for CSV file, if the path I used is wrong, then let's see what is the output. I am using some path name on my VM. Let's see what is the output. See, it's coming an error because in my device, no such file exists. So this is how you import CSV files and work on it. Guys, are you clear how to use a CSV file? If you are, give me a thumbs up or may write in the chat box. Guys, if you have any doubts, raise your hands, please. Guys, listen, this is a very important part because all the data set you will be dealing with ML project, you will be using CSV format. So if you have any doubt, please share. So guys, I see there is no issue. That means you have understood because you will be using this when you're doing the project. So let me move on to the next. I told you that you will be using libraries in Python. So two most widely used libraries are pandas and numpy. Now let's learn pandas. What is pandas? Rather than being a friendly and cheerful animal, it is a very powerful and open source Python library. So pandas library is used for data manipulation and analysis. Analysis means you are using it for any project or any work. You need to see which data, which values are there, what are their significance. And manipulation, you need to edit the data for some required purpose or to do some task. You may need to remove the data, cleaning of unnecessary data. So manipulation is that. Now, where is pandas library used? Why do you use it? Pandas library is basically used for dealing with data in tabular format so that you can correlate your data very good way and you can manage them with proficiency and efficiency. So pandas library is an essential tool for data analysts and scientists and engineers, for professionals. I told you, for proficiency and efficiency. Then why pandas uses came into being? What was the scenario prior to pandas, when pandas was not there? Prior to pandas, Python was only used for data preparation and small management and storing, but it was very difficult to analyze the data properly and manipulate it. So pandas solved this problem. Using pandas, we can accomplish these processes by loading, preparing, manipulating, model and analyze. You are going to model, you are going to make a model. So you need to model the data set to the working model. So pandas solve that problem. Now you can clean your unnecessary data and make a data set or a file which is required and very relevant to you. Now let's see how to import pandas library. So I told you it's a library, you need to import it. Import keyword is used. So do you see any difference? PD is used as an alias. So I am using PD just an alias so that I don't have to use pandas in the rest of my program. I can use a short word, you can PD I have used, you can use any alias as you wish. So this is the first example I have given where I imported the pandas library. I gave an input data set, the user input in a form of dictionary. And this is the variable that stored the data set. It's a dictionary. Well, these are the key and the value. As you have learned, dictionary are the key value pair. This is the function, data frame function, and takes the argument of the input data to print. And I have printed my var is the variable I used to store the data. This is the output with columns and rows. These are the row numbers. I will be explaining you data frame later in this pandas section. So wait for it. Before that, let me tell you about pandas series. So from hearing series, what the first thing that comes to your mind? It's sequence. It is a one-dimensional array holding data of any type. So, one-dimensional array, it is not in tabular format. That's the difference. Not in tabular format. Just like any list. But what is the difference? Let's see. This is the input data I gave in terms of lists. And I have imported the pandas library as well. Now, I am getting the series using this function. This is the syntax for creating a series in pandas. Series equal to pd series, and it takes argument as the input data name, data set's name, and I have printed the series. So guys, do you see here something? While printing lists, have you ever saw that with values, its indexes are printed? Because lists only prints the values or the required values if you set a loop or you give any particular index. But here, these are the automatically generated labels. In case of pandas, we call it labels, which we call index in case of lists. These are as well printed in the output. So, and this is the series. The series is in the particular manner. These are the values. The labels are similar to list. So, as in list, each element is assigned an index. Here, label are assigned to each of the values. We can particularly select any value by using this label. See, I have printed a particular value 9 from the label 3. This is the single print series. Similar to list, we are using the labels. This is another example. So, let me give you another example where I have created a list. Let's see what's the difference is here. Before, I get the input at list of numbers. But here, I have declared my input data set categories. Let's say, in the form of dictionaries. And you know, dictionary key value pairs, these are the keys J1, J2, and these are the values. Then I have created another series using the same function pd.series gallery. I have created the function. In the output, do you guys see any difference? See, the labels, before the labels were in numbers as they were generated by the pandas library. I didn't give any labels, I didn't specify, but you give a dictionary to specify the labels you are going to have in your output so that you can correlate your data better and you have a better understanding of your data. That's why you are using dictionary so that the labels will be the keys respectively. So you can use the keys as label. I have given another example where I have printed the values of the dictionary using the key as a label, date 2. So this is all about series where we create one-dimensional array and create a particular values using the labels such as indexes. This is pretty similar to list, but the difference is you get to see the labels, not like list. In the list, the indexes work in the background, but here you get the labels with the output. So this was the building blocks for data frames. This is the main part of pandas. What are data frames? Now, data sets in pandas are usually two-dimensional tables called data frames. Pandas data frames are mutable and heterogeneous tabular data structured with labeled axes, rows and columns. Why did I call it heterogeneous? So see here. You can name the columns, numbers or strings or any data type and give them values and another data type. See, the keys here are strings, while the values I use a list for both the cases. So this is a heterogeneous tabular data structured with labeled axes. Axes means rows and columns. A table with axes, columns and data and the rows. So let's see, work with what is the difference between series and data frame before working with data. Series is like a column. Data frame is a whole table. You know, you need to use the data in tabular format. So here is an example. I have given the input data set transformers. Say these are the column names, Autobots and Decepticons, and these are the values I have gave lists of the certain names. This is the group variable I use to store the data frame we are going to obtain in the output. And see the data frame function, you need to understand it. What does the data frame function? And remember the syntax. See, D and F are capital while others are small. This is the syntax. You need to maintain it while writing the function. the data frame requires some arguments properly. The first argument it requires is that the name of the data set you gave as an input, and the column names you are going to have when you get the output. So this is the complete syntax for making a data frame from your input data set. Now I have printed the data frame. See, these are the columns, these are the rows, these are the respective level of the rows. This is the complete table of my data set. Now if I require a particular row or any particular value, then what do I need to do? I need something assigned to that particular row to get that. So locate keyword, LOC keyword is used for that. Similarly as label, but this is a function. Label was just assigned to the variable, but this is a function or locate attribute. Now print group.loc, and this is the label. Locate attribute is used to get particular rows. These are the column names I have, and I have got the rows. Guys, do you have any doubt until now? Because this is an important part. Data frame is used to declare the data set in terms of data frame. So you need to clear your doubts about it. If you have any doubts, may raise your hands. Is there any issue, guys? Please let me know. So there's no issue. Okay. Need to remove some rows and columns. So I told you, we need to use the drop attribute for that. But before that, I told you that pandas library can get us any data set or file with relevant data by removing the unnecessary or irrelevant data. How do you need to do that? There must be some functions, because libraries contain functions and many attributes that makes your works efficient and makes you deal with their work with a better way. So therefore, the drop attribute is used to remove unnecessary data from your data set. So I have imported again the pandas library SPD, and the same example as earlier, the transformers data set. Sec variable I have used for storing the data frame. This is the same syntax as earlier for making the data frame. Now see the drop function. How is the drop function used? Please listen to this explanation properly. The arguments here, set drop function is used. Decepticons. This is the column name. This second column. Decepticons. The column which I am going to remove, and this is the axis. The axis is the keyword that signifies your rows and columns. If you give the axis value 0, that means you are considering a row. And if you give the axis value 1, then you are considering a column. So here I have given axis value 1. That means we are considering a column. And in place is true. Guys, do you know what in place means and why it is taking a boolean value? It will only take boolean value, either true or false. But why is it taking? In place is a keyword that makes sure that your data set, what you are doing with it, it is only doing in the front end. Okay, so it is not actually changing the data set in the memory storage. You are using to present it. You can still, after using in place, you can still get the original data. So see, if I, and this is the true. If I use the false here, what will happen? Let's run it. See, that I told you the data set will remain the same. It will contain the same. You are just getting on as required for your task, but the data set you gave will not change. It will still be saved in the memory at the back end. So see, you are still getting the column. See, if I am giving it true, then you are getting, see, the column 2 is deleted. Now let's see. This is the procedure. This was the procedure for removing a column. If the column was not deleted. Now let's see if we can remove the. I am copying this. Wait. Let's see if we can remove a row. This was the column name, guys. Column names are Autobots and Decepticons, but for row, there are no names, okay? For row, there are labels. See, 0, 1, 2, right? So let's remove the last row, which has items, hound and bone crusher for Autobots and Decepticons respectively. Let's see if it is removed or not. Guys, do you see what is the mistake? 2 is not found because, guys, because I have used a different tab, but here if I do the same thing, see guys, 2 is not found in the axis. What does that mean? That means that there is no row with a label as 2 here. There is no row because I have already deleted now. And see here, axis is 1. What did I tell you? This error is coming because I have used the axis 1 and there is no name as this was 2 because axis 1 means you are considering columns, right? Columns. The column names are Autobots and Decepticons. 2 is not there. 2 is already used for the last row. So if I put the axis 0, right? See, this was necessary because if you put the axis 1 and you are giving any other name, it will not come. So you need to remember axis equal to 0 or 1. If you are giving your axis 0 and running the same program, see, right? The last row is deleted because 2 is the label or the name, the last row. Okay, so remember the names you are using must be in the table or the tabular data format as the name of columns and rows, and consider the axis value file you are doing the code. So this is for your pandas library. You have understood about data frames and a series, and you will be using it later while doing your projects because pandas is an important library. So guys, please let me know if you have any doubts in the data frame section because this is required. Is there any issue, guys? This is an important topic, guys. Pandas library and NumPy library because these libraries are widely used even by professionals. If you have any issue, you may give a thumbs up. Okay, guys, so be excited because after this the Python will be over. Okay, so you will get to do projects in the second half. So wait, and another section of Python library is coming. So I am handing over this part to my companion Rishi.
So I hope guys, you all are clear with the basics of Python and the pandas library. Now we will further move on to the NumPy library, which is one of the most useful and important library when we are dealing with the data analysis. So what is NumPy? NumPy is an open source Python library which is used for working with arrays. The word NumPy stands for numerical Python. So why do we use NumPy? As we already know, in Python, we have lists that serves the purpose of an array, but they are very slow to process. Whereas NumPy aims to provide an array which is about 50 times faster than traditional Python lists. So how to use NumPy library in a program? So to use NumPy library, we simply have to import it in our program. Here I will write import NumPy. Here I will import NumPy as an alias. You can use any alias. As an entry alias, you can use any alias. So when I will run this cell, the NumPy library will be imported in our program. So now we will learn how to create a NumPy array. To create a NumPy array, we use array functions which take a list or set as an argument. For example, if I take a variable name array1 equals empty, here I will pass an list as an argument. So let's take any list. So when I will run this cell, this will create a array1. So now I will print this array. So we can see that we have successfully created an array using the array function. So now we will discuss about how to assess the elements of an array. So we can assess the element of array using their index value. So to assess the element, I will write the array name. For example, here I take the array1. So I will write the array name and then I will enter the square bracket and I will enter the position, the index value of that element that I want. For example, here if I write 0, so what is the output of this? Here we can see that in the array 1, we have 1 at the index value 0. So when I will run this, we get output 1. And similarly, if I write any other value, for example, I write index value 2. So what is the output? So you can see at the index value 2, the 2 is located in the array. So now we will discuss about the attributes that are used in NumPy array. So what are attributes? Attributes gives us the additional information about the properties of an array. Here we will discuss the 3 main attributes with the shape, size, and detail. So what does the shape attribute do? Shape attribute provides the dimensions for an array. For example, if I write my array name, which is array1, dot shape. So what it will give? It will tell us what is the shape of an array, that how many rows or columns are present in our array. So here I will run this cell, and we can see there the answer is 5. The output is 5. So what does 5 means? That there are 5 elements which are presented within our array. Now we will move on to the size attribute. What the size attribute? Size attribute tells us how many total number of elements are present in our array. For example, in our array 1, here we can see there are 5 elements. 1, 2, 3, 4, 5. So if I write this array name, array1 dot size, so what will be the output? So the output will be 5, as there are 5 elements presented in this array. So here we can see clearly said that the output is 5. So now we will learn about dtype attribute. So what is dtype attribute do? Dtype attribute tells the data type of element of an array, and it also tells about how many number of bytes are allocated to each element of array. For example, if I write my array name array1.d, and then when I will run this cell, we get that the output is integer 64. This means that the data type of our array is integer, but thus here the 64 represents that there are 64 bytes are allocated to each element of the array. And in NumPy we can also dynamically allocate the number of bytes to each element. For example, when we are assigning an array, let's take this array again, print this here, and to change the number of bytes, we can here write np dot. We can write the data type of the array we need. For example, if I write integer, I want number of bytes 8 that is to be allocated to each element of array. For example, 8. And when I will run this cell, now when we print the array 1 again, we can see that here the data type is changed to the integer 8. It means that 8 bytes are allocated to each element of the array. Now we will discuss about types of array creation using NumPy. As we have already discussed about how to create an array using list. Similarly, we can also create an array using set by using the array function by passing in set in the array function. For example, here if I take that array is equal to b dot array, and if I will pass any set here, for example 1, and then when I will print this array, we can see the output. Sorry, there is some error. Here the array is comma. Here we can see we create a set array where we pass the set as an argument is an array function. Here we can see that the data type here is not a integer or not a float data type. Here the data type is object. This means that we cannot perform any mathematical operations like summing, multiplication, average on the set array. That's why the set array is not good for the mathematical calculation. That's why we avoid it most of the time. So here now we will move on to the interesting NumPy array creation object. So what is interesting NumPy array creation object? They are the built-in function or the predefined function in our NumPy library, which allows us to generate arrays with some specific properties without manually manipulating the elements, the value of the element. First, we will discuss about the zeros function. So zeros function helps us to create an array of desired shape and size with all the elements filled with zero. For example, if I want to make such type of array, I will take any variable name 0 equal to e dot zeros, and here in bracket I will specify the shape of an array we need. For example, I need an array of 4 rows, 6 columns in which all the elements are filled with zeros, and here I will print this. So let's see what is the output. We can see that we get an array of 4 rows and 6 columns in which all the elements are filled with zeros. Now we'll discuss about the linspace function. So linspace function helps us to create an array in which each of the element of an array have same gap or linear space with each of the neighbor elements, and it takes three arguments as an input: the start, stop, and num. So start is the starting value of the sequence, stop is the ending value of the sequence, and num represents that how many number of elements we want in our array which are evenly spaced with their neighbor elements. For example, if we take any variable named polygon linear equal to an A of in space, and here first, let's take first argument as 1, second is 10, and third 30. So what it will do, let's see. When I will run this cell, okay, I will print this cell. So we can see here we get an element which is starting with the starting value 1 and end with the ending value 10, and we can see there are 13 elements which are presented in an array which have even space with their neighbor elements. Now we will move to the empty function. Empty functions helps us to create an array of a specified shape and size and data type, but without initializing its element to a particular value. It means that it creates an array of our desired shape, but we didn't have to manually input the values. All the values will be random and the garbage values, or whatever we call as garbage values. For example, if I write any variable name is equal to np.empty. Here I will specify the shape of an array. For example, I take 2 rows and 3 columns, and when I will print this array, we can see that we get an array of 2 rows and 3 columns. In each of the elements are random values or whatever columns garbage values. Now we will move on to the identity matrix. So what does the identity matrix do? So what is the identity matrix? Identity matrix is the square matrix in which the diagonal elements are 1 and all the elements except the diagonal elements are filled with 0. For example, I take here a variable name iden is equal to np.identity and for example, if I want to make a square diagonal matrix of order 3, what does the order 3 means? Means that I want to make a matrix of 3 rows and 3 columns which is a diagonal matrix. For example, here if I write 3 and then we print this matrix. So we can see we get a diagonal matrix of order 3 with 3 rows and 3 columns, which is a diagonal matrix, and all the diagonal elements are filled with 1 and all the elements except the diagonal elements are filled with 0. Now we will learn about arrange function. So for example, what does the arrange function do? For example, you have to make a sequence from 0 to n, any n-1 position. What does the n-1 position here means? For example, I take any number here 15. So what does this function do? It will make an array which is starting from the value 0 and it will end till the n-1 position. So what is n-1 position? Here we can see that we enter the 15 as an argument. It means that our nth position is 15. So it will create a array from 0 to 14. So when I will print this array, we can see that we get an array which is starting from 0 and enter 14. So let's now move on to the NumPy axis. So what is NumPy axis? NumPy axis refers to the dimension along which operations like summing, averaging, or applying function are performed. So it means that it gives us the idea about the direction of flow, that we are performing the mathematical function in the vertical direction, which is axis 0, or in the horizontal direction with axis 1. Here we will see that how it works. For example, we take any 2D array. Here, for example, we take this array. First we will learn about sum function. So sum function help us to compute the sum of array element along a specified axis or across the entire array. What does it mean? For example, if I use the sum function here, for example, if I write array 1 sum. So if I run this LB, we will get the sum of all the elements which are projected in this array. First, we can see it is not an array, it is a list. So first we have to convert it into an array using the array function. Array 1 is equal to array. Here I passed array. So we successfully created the array using this list. So when I will run this cell, we will get 29. It means that the sum of all the elements which are presented in this array is 20. So now we will learn how to use axis. For example, if I want to perform operation in particular direction, for example, I want to sum these elements or sum these elements in particularly. So I can use the axis. So what to do? I will know the array name sum. And I will specify the axis along which I want to perform the function. For example, here I write axis equal to 0. So it will make an array by summing all of the elements in a particular direction. So let's see what is the output. And we can see that we get an array 12, 8, 9. It means that 12 is the sum of all the elements in the axis 0. Here this column axis 0 and this axis 0. So now we will learn about what is transpose array. So when all of the vertical rows, all of the vertical columns are replaced by the horizontal rows, it will call the transpose of an array. So to transpose the array, we use .t function, .t attribute. For array 1.t, if I will run this cell, we can see that here we get the output as a transpose of this array. So there are two more attributes we learn, which is n dimension and n bytes. So what does the n dimension tells us? And the n dimension attribute tells us how many number of dimensions which are presented in our array. For example, our array is a 1D array, 2D array, and further on. And what does n bytes do? N bytes tell about how many number of bytes that are consumed by an array. So if I write array 1, here I will get the output as 72. It means that 72 elements, which means 72 bytes are totally consumed by this array. So if you guys have any doubt, you can ask now. Give some thumbs up if I will further move on so that I will. Okay, I get a thumbs up, so no doubts. Now we will move on to the rmin and rmax function. So what does this function do? These functions, it gives us the index of the minimum or the maximum value of an array. For example, here we can see we take an array. So when we use the rmin function, it gives the index value of the smallest value of an array. Here we can see the smallest value is 1 in this array, which is located at the 0th index. So when we will run this cell, we get the output is 0. It means that the smallest element is present at the 0th index position in this array. Here similarly, we use the argmax function, so it gives us the 8. It means that the maximum value is presented at the 8th index of this array. And here is argsort. What does argsort do? Argsort tells us all that what will be the position of the values, what will that gives us the index of those values in which we will, when we will arrange the array so that it will get sorted. Then we can see that our array is already sorted, so the index value is same as that of the same array. Here we use the access function by performing the argmax and argmin functions in a particular direction. Here we will move on to the reshape function. So what does the reshape function do? Reshape function in NumPy helps to change the shape of an existing array without changing its data. For example, here is our arrays. Where here we take our array is this array 1. So if I want to change the shape of this array, we'll write np reshape. And here I will specify the shape. The shape in which I have to change the array. For example, here I will write 9 or 1. So when I will print this array, we will get output as here some error, minimum error. For example, here we take this array. Okay. So when I will reshape this array, I will enter the shape. I want to change it. For example, write 3 by 3. Here we can see that the output we changes this 1D array into the 3 by 3 2-dimensional array. So here we take an array 3, and so in NumPy library we can add the respective element of an array. Whereas here we can see that we added this array 3 plus array 2. This array with another array 2, in which all the respective elements are added. But if we use a normal list which are present in Python, it will not add a respective element. It will append the list. And in NumPy array, we can also multiply two arrays. Their respective elements will be multiplied. And here is one more function which is square root. So what does square root function do? It gives us an array of any existing array whose all elements are the square root of that existing elements. So here my NumPy part is completed. So if you have any doubts, you can ask now. So if you have any doubts, you can ask, really. So I can see no doubts. So guys, I hope that all of you guys are clear with NumPy library. So that is all for this Python segment. Take some time to go over what is covered, and we will dive into the next part, which is more interesting, and you will learn about the model training. So have lunch and return back on a specified time. Thank you. See you later. And the time is 2:30. Okay. Thank you. See you later.
Okay, everyone, welcome back to the session.
I hope you all have imported the files like the drive link which I sent there, because that's the data set which will need during the model building. Okay, and also make sure that is first. There are some needed packages or modules and stuff. You need to install it. If they're already installed, you can just directly import them. The TensorFlow, Keras, Matplotlib, as you can see on the screen. The first tab, you can see these are to install it if you don't have it installed in your system. Okay. If you have it installed, just import them. Not just that, from the framework and stuff, you also need to import certain things. Like you can see here, TensorFlow. Here, this is a framework where we are going to build our CNN model. Next, OS. This module helps us to traverse to the directories and take the files, access the data files, whatever we need. And whatever the stuff are there, I'm gonna not teach you the specific application of this, but obviously I'll mention how we are gonna use this or apply this in our CNN. Then here you can see I here you can see I use the drive because my data files, whatever it is there, it's in my drive. From the drive, I'm gonna import it. See, I have an option here, connect to Google Drive. Use your Drive account in which you have put that data set, okay? And you can see that I've accessed the drive now. After that comes the path where you need to set the path to your directories. Here you can see there is an option drive for me. Then my drive. I have the data folder here. It contains my data sets like train and validation data sets and also an Excel file. Look closer here. I've given the path according to that. The drive, the my drive folder, and then the data folder, the train, valid. Then you will be importing again pandas and numpys. We'll be using this in the mathematical operations or to access the particular file which is in the data. So we can process it and feed it to our model. Then also I need to set the path to the Excel file which I have. Take a closer look, put all the necessary files. Once you're done, give me thumbs up. going on. I hope you have imported all the necessary stuff and set the path. I've shown you the logic, right? How to set the path. I'll show you once again. Drive, my drive. I have the data folder here in which I have my data sets train and valid. The content of those folders like with helmet and without helmet. Just mentioning to you, we are making a classification model, okay, where we are going to classify the images based on whether the person is wearing a helmet or not in the images, okay. This is the, obviously the main focus here is on the structure, and this idea of helmet and no helmet is one of those applications, okay. Focus on the structure. Applications, there are many applications. You will be able to make many models on your own once you understood this in a clear way, okay. Then I am using a data generator, because you know what data you have is a raw data. You can't just directly give it to the model. You need to process it a bit and stuff. For that, you know, you create data frames. This is the image directory part, and obviously you're not gonna feed the whole data to the model in a single time, right? You're gonna make batches. There is a batch size, target size. This is the target size is nothing but what the model expects. Okay. Then the class mode. And as I have already mentioned that it is a classification model that classifies into just two ways, that's with helmet or without helmet. So it's like a binary, right? 0 or 1. So class mode is nothing but binary. Here comes term augmentation. As I already mentioned, the data should be processed right. And in augmentation, we do that. Like we randomize it in multiple ways. I'll show it to you the later part, okay? And then the indexes. Because when the data is there, we need it in an organized way. That's why we use indexes. This is the length of the data frame, batch size, and yeah, fork and see. This term will come to this term again, but let me introduce it to you. Fork is nothing but the during training we do multiple sets of training. One is called epoch, and after every step, you know, we'll shuffle it, like we'll randomize it. So that's when we'll be having the more probability to get the right result. And now how we'll be accessing the data, like making it ready so we can feed it to the model. Have a look at this function. This is a get item, self index are our arguments which we are passing. I'll make batch indexes. Well, this is one good thing in Collab. Actually, you know, I've already done this. You can see it's prompting me to do that. So I'll take it, but let me explain to you so you can understand it. Batch indexes. See, I've already told you we made indexes so we can organize the data, which makes it easier to access it. You can see index star self batch size. That means in a single batch from the first element to the last element. Make it data self frame elop batch index. In a certain batch of data, as I already told you, the indexes we have listed the indexes based on the batch size, and we've made it into separate groups. Now we are putting separate groups one by one. This is very important step because we need to provide the data in such a way that it becomes easier for the model to take it and to process it and to generate the results. That's how you can make the training process easier and also get a higher accuracy. and this images and labels. As I've already told you, there are two types of images, right? The with helmet one and the without helmet one. This is what you call label dataset. I'm sure you have heard of this in the yesterday's session. It's like a function f of x to y. You're going to train the model on that function, and now I'm giving an image as an input. So it gives me the output, to which part it belongs, like to the one with the with helmet or the one without helmet. Okay. Now we have the images, right? It's time to take the images one by one and load them. Take the images one by one. Here you can see the OS which I have mentioned. Yeah, you can say I've been making changes because it gives me the default thing, but it's just a prompt because you need to know the stuff like how you need to change it according to the parameters which you have given, or into the parameters what you need. I hope you're doing it parallelly along with me. Have any doubts or stuff? Just raise your hand, okay? You might be wondering what this is. If anyone have gone through the data set of the images, you'll be able to see that, in the image, not only the person with or without helmet, whatever it is, you also contain some other stuff. You can call it noise because basically that has no use. Your model only needs the part of the person with or without helmet, but whatever the other stuff is there, it's not really needed for the model for training or anything. Okay. What I'm doing here is I'm just cropping the image so that I can just eliminate the noise or stuff. You might wonder how I'm doing that. In that data set, there is also an Excel file, or you can also call it CSV file, whatever. In that, the coordinates have been given. You call this bounding boxes. You'll know about this sooner, okay? Now here comes the term augmentation again. Make sure you pass the parameters correctly, because if you don't, error arises. After we made it into a list, we need to convert into numpy arrays. Just as I told you, the numpys and pandas, we use that for mathematical calculations, and obviously we are going to do the same thing here. While extracting the features or while recognizing the patterns, everything happens in numbers here, okay? Yeah, and indentation is one other thing, because in Python, that's what really matters. Similarly for labels, yeah, this time I did skip the prompt it gave me, because mine was easier. Now let me make a slight revision kind of thing here, what we have done again. Because right now we have a data set properly ready, we just need to augment it and then feed it to the model, okay? Going through the imports and stuff, TensorFlow, the framework, and OS to access the stuff. And now you're gonna know about sequential and all this stuff. We need these terms here. While I'm gonna build the architecture, I'll be mentioning how we are gonna use this. So that from the data set, like I access my data set through my drive. I've shown you how to set up the path, and then also some other necessary imports, and also the Excel file that contains the labeling and stuff, and also the coordinates how to crop the image. Then comes custom data generator. Yeah, here you can see the sequence. I told you why do we need to generate the data, because the raw data can't just directly feed, you need to process it. We made the indexes, we organized our data, we divided it into batches, then took the batches again, made the list, and now the numpy arrays form finally. Here comes the data generators. Okay, it's time for augmentation. In augmentation, basically what you do is whatever the data is there, you don't take it directly. You'll just make some slight changes into your data. Suppose you have an image, then you're gonna make that image black and white. So now you have two images, which one is a colored one and the other is a black and white one, so that your model becomes familiar with that case also. Okay, that's what basically you do. And here I have selected a few parameters. It's the few things in which I'm gonna make changes, like the rotation range. Let's say that I'm gonna rotate my images at an angle of 30 degrees. 30 degrees. And you can also shift the width and height. Width shifting 0.2. Like it means that 20% of the width. I'll take the same value here. Zoom range. Of course, some images will be zoomed and some gonna be like zoomed out. Even that cases you need to consider, right? Let me take the same values. 0.2. And of course, flipping. horizontal flip. I have considered horizontal flip and fill mode. This thing is if there are some empty values there or if there are some missing values there, we just fill it according to the nearest values based on the average or whatever. And brightness range. Let's think I'll be putting it to 0.8, like I'll be bringing the brightness to the 80% of what it is there, or I might increase it to 1.2. In validation spread, well, already you know about validation, which is an important part here while training the model. So I'm going to split a bit of data for validation, just say 0.2 again. Fine. Good enough, I guess, for the augmentation. For validation detergent, I'm just gonna take whatever the image is. I'm just gonna rescale it and I'm gonna take it direct. Not doing much changes to the validation data generators, data for validation. Train generator. Say to create the custom data generators for training and validation. The data augmentation is done. Now we're just gonna generate the data and feed it to the model. Consider target size. That's what I told you. What the model expects, right? This we give it 64, 64. This is the order. Like there are matrices like 8 cross 8. This is the same one. Batch size. I'll take 32. These values are not like strictly you need to take these particular. There is no any limitation or rules. You can just randomly take it and adjust it accordingly so that you get a model where there is higher accuracy, higher efficiency. Okay. In class mode, it's binary because there are only two cases, 0 and 1, and you know what those two cases are. Yeah. Yeah. We're good, I guess. Say they have been found like 4060 emails belong to two classes and 423 emails belong to two classes. Fine, let's proceed. Yeah, just to let you know, right? The print generator class indices, just as I told you, there are two cases, and also the train generator had generated the images according to what the model desires, according to what we see the batch size and size of the image. And 3 is the the number of channels. Like it's an RGB image, so there are 3 channels. Here's the first part is done, where we have accessed the data and we have done the augmentation. We have generated it. Now the model's data is ready. The model is not yet ready. We'll be constructing it. Okay. I'm thinking that you are able to catch up. If not, just raise your hand so I can know. Because I know this part is like really new to you. Don't worry. I'm right here to explain you everything. Give me thumbs up if you do have a brief idea, like you're clear. If you're clear, give me a thumbs up. Just raise your hand if you're facing any issue. Till this part. If you want me to slow down, yeah, okay. Just do the necessary stuff. Do the imports. Hope you all are done with the importing or installing stuff. Of course, if you have a bad internet or something, it might take some time. Even I am from Hall 11. I know it. I also hope that setting up the path is also clear because it's really important. And then generating the data. Don't worry, these files and along with the code, everything will be shared to you at the end of the day. Fine. Think everyone is good with this. Now comes the very important part, that is building the model's architecture. Because this is where you build the structure of your CNN model. Should be coding parallelly with me, okay? Okay, what are regularizers? Briefly, we use this to prevent overfitting. I'm just mentioning. Yeah, this time the prompt helped me out really well. Okay, coming to Convert 2D. This is one of those which we have imported at the beginning. Convert 2D, we use this, it performs a fundamental operation like the recognizing the structure or the patterns from the data. It recognizes those like the features, whatever it feels like important to make the decision or to identify or to classify. It recognizes those and just stores with it. 3 cross 3 is its size, just as I told you, like there are matrices, right? That's all. Activation function, this is the input shape, what it desires. Apart from this, I wanna add something, which is padding. Same. Padding, I think you heard about it already in the yesterday's session because they taught it. If not, padding is like, suppose you have an image and you need it in the desired shape, but obviously what image you have is not in that, right? You need to convert it. So what do you do is you just add some empty pixels so that you get it into a desired shape. But just think to change the size of my image, I've like zoomed it a bit too much, then it looks very disgusting. That might hamper my model's speed or efficiency. Yeah, but let's build some more layers, okay? Because we need many to extract the features. Yeah, this 32 and 64, these are the filters, okay, that are gonna take the features. Each filter is gonna take the features. In 64 filters, I don't wanna increase the filters too much. So let it be 64 itself. Inside be adding 4 layers, 5, 64. Okay, let me take 1 for 128. Yeah, every part of this decides how accurate and how efficient your model is going to be. Of course, you will not be able to know these values initially itself. You need to make the model and then you need to trial. It's like a hit and trial method. If you are really good at concept, you can understand it and you can do it in the first few tries. And then here it's a flatten. The flatten, it's a function what converts. Suppose just think there are a few dimensions. The dimensions are like the number of parameters, suppose, which are gonna affect it. Suppose if there are too many, it causes me trouble. So the flatten, what it does is it just converts it into 1D, one dimension. And here obviously you will be observing after every convert to the layer there are batch normalization and max pooling rate. This batch normalization, it normalizes the input data across this batch. So it makes the model more stable and accurate. And max pooling, it reduces the dimensionality again. But finally the flatten converts into totally a 1D. And in the end, let me use dense layers. No, not big numbers this time. It's gonna go with 10. Need an activation function. Yeah, the regularizers, which I'm gonna need very much. I've used, there are two types of regularizers. I've used both. They are like, I'm not going into the deep, but I'll be mentioning them soon. This values I'm gonna give here is learning rate. You might see why is the learning rate so less. Actually, I'm going with the motive that I want to make sure my model doesn't overfit. That is why. Then comes dropout. Dropout in simple words is like when you have a certain parameters, of course you're gonna check what is the weight of each parameter. But to make it more randomized or to avoid certain problems like overfitting or any other, what we do is we just neglect some percentage of it and train over the other parameters and then randomly select some percent again and again, neglect it and again train it. So dropout 0.3, that means 30% of the parameters then neglecting. Random, we are picking them randomly and then we are neglecting. And again we are going to pick a 30% of other. We are going to do the same. Another dense layer here. Again, I use the regularizers. But after this, I want to check my model summary. Good. Now you can see everything good. Like output, shape, parameters, pooling which you done. Here you can see every time we did the pooling, becomes by 2. That's what the pooling does. Reduces the parameters so that the computational load, it decreases. It becomes easier. Finally, flatten in the dense layers. See the total parameters here. Total trainable parameters again, non-trainable parameters. Finally, I'll just give a quick revision here because this is really important. This is the architecture of your model. This is the structure of your model. Here we have used the layers activation functions, we use padding, we use the batch normalization, and we pool the layers, the number of parameters, decreasing it, we are extracting the features and also making it easier for the model at the same time. Because when you are developing a model, that is our motive. We need the features, but not in that level that the model gets, the model struggles to train itself or whatever. We need to make it easier for the model also without losing the important features. As you can see, I have taken some number of parameters and then like 6 layers, I guess. And in the end, I put the 128 filters because like each filter takes up each parameter. And then in the end, dense layers. Okay, the difference between these convolution layers and the dense layers. Hope you know because this has already been taught. Now the thing is the convolution layers, right? The neurons, whatever is there, they just select connected with the previous ones, like like a stack. Coming to dense, it's not like that. Like suppose in a dense there are 5 and in the previous layers there are like 10, then every one of it is connected to the every one of those 10 and every one of those 10 is connected to every one of those 5. These are the layers that's gonna take and finally decide the output and they're gonna show it to you. Give me a thumbs up if you're done with writing code for this architecture. If you have any doubt, please raise your hand. Even in the data processing part. Okay. Fine. Now the data is ready and also the model is ready. It's time to train it. First, let me import some necessary stuff. Yep. Again the prompt, really good one. I wanted to import the optimizer. Here I have an imported optimizer named Adam. Like what this contains is, this is going to help me with the training to make the process easier and efficient. So we have imported early stopping and model checkpoint. I'll be mentioning what these are. Actually, I feel like I went really quick with the model architecture and hope you have followed, but no one has raised a hand or stuff, so I'm continuing it. If you're having any issues, like don't worry, as I've already said, by the end of the day, you're gonna get all this material. What's the learning rate? Exactly, the learning rate is 0.001. Now we have given that learning rate specified, like we mentioned it explicitly that at this learning rate this should happen. Then we are going to compile the model. And the thing which we are focused is on the accuracy. That is why you can see the metrics are mentioned accuracy. We are concerned with accuracy of the model. But the blocks are finished. Okay, and another new term here, reduce LR on plateau. This is one other interesting term we'll be mentioning right now. First, let me mention the terms early stopping and model checkpoint. Okay, as you can see here, what we are monitoring, val loss. Like in the validation, if there is loss, and our target is to minimize the loss function. Patience 10. No, bro, I don't have that much patience. I'm gonna put it to 2. And we don't need this because we are using a checkpoint anyways. Okay. The thing is, suppose we are monitoring the loss and we are going through the process of training and validating. But the thing is, the loss isn't going down after even like a number of tries isn't. Then you can use this early stopping because I want my process to end quick. Don't have much time. I can't take all the day, right? Because time is really important here to be efficient. Sometimes even this can happen like for like 4 to 5 steps, you know, the loss function doesn't go down and then suddenly it might. In that case, I'm going to use the early stopping, so I will be monitoring the val loss for like, if it doesn't go down for the next 2 tries, then I'm going to stop my train. Okay. Now, reducing the learning rate. So you can see what we are doing is we are observing, and we are like if you are finding that the problem mostly, you know, the overfitting happens. And what we are going to do is we are going to reduce the learning rate. For that we give a minimum value. Let me take it down. Let me give it 1. In fact, no, I'm gonna half it for each instance. Okay, no, I can't keep both values equal. We keep it 5. Suppose for 2 tries, you know, the value isn't going down, then I'm gonna lessen the learning rate. Like I'm gonna make it half and try again. And if it doesn't happen for the next 2 times, I'm gonna make it half can. And if it doesn't change for the next 5, like if it doesn't go down, I'm gonna stop it. And suppose we have reached a point where we got the best weights for the parameters, then we should save it. That's where checkpoint comes. Errors, fallbacks. Best model dot errors. Suppose at some point we got the best model, then you're gonna save it. Save best only. True. Okay, someone raised the hand. Please give him the permit so I can talk to him. If there is a possibility, send your query in the chat. Raj Guru says great part, and also the checkpoint to save if in case we get any best model there. And of course, we'll get at some stage in the graph, we're going to get the one with max accuracy. Train generator, because this is where like I'm going to take my data from. I'm going to take batches of size 10 here. Box. Let me make it 16. I've already mentioned this term box, right? The number of clients we're gonna train the model at, and divide it into batches and feed the model and train on it. For validation data, we do have a validation generator. Similarly, we need the validation steps. Yeah, I'm fine with 10 here also. We also define the callbacks. Everyone, this is the another important part. First one was the data augmentation or processing the data, and then it was building the model. The data part where we have accessed the data and we have done the augmentation. We have processed it very well so that we can feed it to the model. We have separated into the classes and stuff. And then here comes the architecture. We have built the layers, used the activation functions, done the normalization and pooling, and we did give some dense layers, and we also used the regularizers to prevent overfitting. We got the summary. I think this is good enough for a simple and straightforward model, whatever we are using here. We did use the optimizers to set the learning rate and stuff. We are gonna measure the accuracy. We have also done with the coding part of training. So run this. And yeah, the model will take a certain amount of time for the training. So this is part, where I feel boring because you just have to sit and wait for the model to get trained. Okay, in the meantime, we did import a thing called matplot library. So one of the models will be need to plot it. And obviously after the training, we'll be having a certain level of accuracy. So now I'm gonna just visualize that for you. Well, to 4, I would prefer 10 to 5. If the prompt is good, but I'll be needing to change the terms. Because, thing which you need here is not loss. It's accuracy. You're focusing on accuracy. Here it is. Training accuracy. And this one is validation accuracy. Yeah. Once the training part gets done, um, we just run this fact and you'll get the visualization of the accuracy. The final step is, so you work really hard to make this model. So don't forget to save the model in the end, okay? Yeah, this name sounds good for me. Once the project is completed, no worries, we'll just give you the free access, like a session where you can interact freely, no any kind of restrictions, like you will be given all the permissions. There I hope all your doubts will be clear. The training is done, then just visualize your accuracy. Also you can work on it, you can change certain ways, like if you feel like you want to take the number of filters in a different way or the image size or the learning rate, you can adjust it and you can try. Even it's in the processing of data or even in the architecture, you can make some changes so you can get the best accuracy. Just a second, guys. Let's have a look at the whole code because all the coding part is done right now. Then the necessary importing and then the Google Drive. After accessing the drive, set the paths and then generate the data. And after it's properly organized, you're gonna do some argumentation to that so that it gets randomized in there. I already told you the purpose of this. This is just to make sure that everything went well, because sometimes it's important. Check at every step that you make no errors and all the process is going fine. You need to be sure of that. Consider this like the first part. Briefly, you can think it of as three parts because the first part consists of handling the data. Second comes the architecture. Here is the model summary. That the model is built and the data is ready. Final part comes train. How well you're going to train this using the optimizers training. The model be trained, even I am kind of excited to see how much accuracy it gives. So model is being trained. I've also given you the code how to plot the accuracy. And then in the end, don't forget to save your model. Because after that, once your model is trained and validated, after you save your model, you can just call the model and upload an image. Then it will do the classification. But for the final partner, we are not gonna use this simple, straightforward CNN model. This was just to explain you how a CNN model works. Or then in the future, if you want to develop something, you need to know what the parameters are, what the steps you need to be taking. Fine. Now we have planned something for you so that you don't get bored. And, that is a quiz. Yeah. Before we begin with the quiz, I want to make sure that you all are clear with the concepts. So raise your hand or react so that we can know. Okay.
So is the screen visible to all of you? Just give the thumbs up if it. Okay, so now we'll begin with the quiz. So here's the first question. So can all of you see the question? Is the question visible to all of you? Guys, react so that I can know. Okay, so the question is, how is the number of items in each dimension of a NumPy array is expressed with? So those who know the answer, just raise your hand and then we'll allow you to write the answer in the chat box. None of you are able to tell the answer. It's a very easy part. All of these questions were discussed in the workshop and none of you had any doubts. So what's the issue? If you know the answer, just raise your hand so that we can allow you and you can write up the answer. Okay. Okay, we have one answer. Okay. Okay, now you are getting answer. Okay, good. Okay, just wait a minute. We'll allow you to write up your answers in the chat box. Okay, we have one answer. Ruchir, it's an MCQ question. You can't give multiple answers. Okay, Shubhankar. Okay, nice. Any more answers? See, it's the first question, so it's the easiest. And if in that I'm getting just two answers, so guys, are there any more answers? Okay, I guess not. So let me show you the correct answer. So exactly, well done, Shubhankar and Ruchir. You guys were correct. The answer is in fact tuples. So moving ahead, the next question. Now, so what is the difference between remove and pop function? So any one of you who knows the answer, just raise your hand or you can just write it up in the chat box itself. Okay, Ruchir has answered and Rohit has also raised his hand. Okay. So any more answers from anyone? Guys, you all can unmute yourself and give the answer. If you are facing any issue in unmuting yourself, just tell us. Guys, are you able to unmute yourself? Just tell me that first. Guys, are you able to unmute yourself? Please answer. If yes, then just unmute yourself and give the answer. It's better than writing the answer in the chat box. So guys, remove function takes the specified element. Here the argument, we give an element, not the index. But in the pop function, it takes index of an item as an argument. That is the difference. The difference is it removes an item. It also removes an item. But in the remove function, you give the argument element and here an index. And if no argument is given, then pop function will delete the last item. Then move on to the next question. So here is the next question. Why do we prefer NumPy arrays for bigger datasets rather than lists? While discussing the NumPy arrays, you must have learned it. Guys, this was taught to you. Any answer? Guys, if you are able to unmute yourself, then please do. Then you can tell the answer. Hello? Or write in the chat box about the answer. Guys, the quiz session is all about being interactive with you so that we can know how much you know and how much you have learned. You need to reply and respond to the questions. Guys, this is not a class test or any exam, so please don't hesitate in answering. Even if it is wrong, you'll get to know the correct answer, so it will benefit you. So please answer. If anyone knows the answer, please answer. Okay, we have few answers from Rupdeep and Rohit. Okay, and Aniket as well. Good. And if you all are able to unmute your mic, then just do that so it will be better than writing the answers in the chat box. You can explain in more detail why do you think that is the answer. Guys, let's see what is the answer is. So as you have said, it takes less time, but that is not the fully correct answer. It is partially correct. It has more efficiency, and this part is important. Contiguous memory location. Do you remember what is contiguous means? But in a list, the data are stored in random memory location accesses. But contiguous means they will be stored serially. So that is the difference. That's why NumPy is preferred, and it has more efficiency than lists to deal with bigger data sets. Now let's move on to the next question. Now this is a simple question of syntax. Which of this is correct? The functions here. Which of this is correct? Tell me the option. Where the correct function is used. Which function actually exists in the Python library? Take your time and give the answer. Guys, answer first. This is a simple question. No explanation is required. You have just to see and tell which one of this is correctly used. So guys, you are not being able to answer the simple question. Let's see what is the answer is. String that capitalized. It was only to identify the correct function I only said. Other functions are wrong. This was the correct function. So let's move on to the next question. Now these questions are different from that of Python. This is about convolutional neural networks that you learned. Day 1. So in CNN, what is the role of the convolutional layer? Option A, to flatten the input data. Option B, to reduce the dimensionality of the data. Option C, to apply filters of input image and detect features. And D, to perform pooling operations. Guys, you will be able to answer this if you have heard about everything about CNN taught yesterday and understood all the concepts. So take your time and give the answer, correct answer. And as you can see, this is a conceptual question of CNN. So give your best for this.
Answer fast, guys.
Yes, Supadeep, that is actually the correct answer. The convolution layer is used to actually detect features. It extracts features with the help of filters. The convolution operation is actually done to do that. So yes, that was a as you can see, your answer was correct. So the next question, what is the purpose of activation function in a neural network? Option A, to decide whether neurons should be activated. Option B, to normalize the input data. Option C, to calculate the output of each neuron. Option D, to reduce the complexity of the network.
Okay, let's check the answer. So yes, the correct answer was A. So Aniket and Rupadeep and Manuparam, you are actually correct. The correct answer was A. To decide whether neurons should be activated. So moving on to the next question. Which of the following activation function is commonly used in the hidden layers of an artificial neural network or ANN? Option A, softmax. Option B, sigmoid. Option C, ReLU. Option D, tanh. We're getting some answers. The main answers are A and C. So those students who have chosen A, softmax is actually used when there is a multi-layered classification. It is not used in binary classification. So we actually use ReLU here, where the negative values are dropped to 0 and the positive values remain as them. So let's see the answer. Yes, those who chose C were the correct option, and their names are Aniket and Ayan and Drupadeep. And then moving on to the next question. What is the purpose of backpropagation algorithm in training artificial neural networks or ANN? To initialize the weights, to compute the error and update the weights, to predict the outputs, to initialize the neuron. Guys, try to answer. So yeah, we got some responses. The main responses coming are C and D. Yeah, those guys who actually given the answer C to predict outputs. Backpropagation actually doesn't predict the outputs. Backpropagation, the model predict the outputs by using the weights and biases. But backpropagation is actually used to find the value of weights and biases by tracking back from the predicted value. So yeah, guys, those who told B, those are the correct option. So please, can you see the answer? Yeah. So the correct option is B, to compute the error and update the weights. So moving on to the next question. Which of the following is a key component of an artificial neural networks? Option A, neurons, nodes. Option B, activation functions. Option C, weights. Option D, all of the above. Yes, Manapuram, no need to say sorry. Actually, this is an interactive way. So yeah, if you give wrong, if you give right, just it is good that you are interacting with us at least. Yeah, we got some answers. Most of them are D and one is A. Yeah, neuron is actually a very important part, but activation function and weights are also very important to predict the output in an artificial neural network. Neuron is nothing but a mathematical function, which actually is the summation function. If you have read yesterday, as we have taught you, that is actually a summation function. And what is activation function? It just brings the predicted value in a range, in a specified range. And weights, they are actually hyperparameters that we have already explained to you before. So yeah, all A, B and C are very crucial components in predicting the output of an artificial neural network. So those who told D, that's the correct option. So moving on to the next question. This will be the last question. So guys, please try to answer this. What is pooling in a CNN used for? A, to increase the size of the image. B, to reduce the computational load by downsampling. C, to add new features to the image. D, none of the above. Please try to answer this question. This is a conceptual question. B, but one is C. So yeah, we actually don't use pooling to add new features to the images. We can't actually add new features to the images using pooling. Pooling is actually used for reducing the computational load by downsampling the images. As I have talked to you before, yesterday, that pooling actually halves the size of the feature map. So it reduces the number of pixels by almost 75%. So we are actually downsampling the image to reduce the computational load on our CPU or our GPU. So yeah, the computational load, and another term is it also induces translation invariance, but that was also discussed in the previous session. So
Can I just see the screen? Please show a thumbs up if you guys can see the screen. Thank you. Let us start with the YOLO part, right? Okay. So now from अभी तो हम लोग ने CNN सीखा, ठीक है? तो CNN में क्या होता था कि एक ही ऑब्जेक्ट था, एक ही इमेज में एक टाइप का ऑब्जेक्ट है. मान लीजिए आपको एक ऑब्जेक्ट है कि एक इमेज ऐसा है कि a person there is wearing a helmet and a person there is another person is there who is not wearing a helmet. What will the CNN model do? It will predict that yes, somebody has the helmet, somebody does not have the helmet. But which person has the helmet and which person does not have the helmet, it won't get detected. Here lies YOLO. Okay. So you might have got understanding why do we need YOLO. For getting a deep understanding, let us also know some concepts like. Let us also know some concepts like what is class description and image classification and object localization. Now let us understand what is image classification and object localization. Now you can see the image in the left side, right? There is a dog. But the CNN model, what will it do? Is that it will detect is there any dog or not. So for dog, it will come out with, it will show 1, and for person it will show 0. Means 1 and 0 are represented as true or false. Okay, it is boolean. It throws a boolean value. Okay, and in the right side in the image, you can see the dog is bounded by a box, which is known as actually bounding box. We will know later on throughout the topic. As we progress throughout the topic, we will know how to make this bounding box also. So be with us. So this is the image in the right side. Okay, there is an image of this type of detection is known as object localization. Okay, what does it does? That it not only detects which object is the dog is present or the person is present. It also shows that it has a bound where the object is present. Is it present at the center of the image? Is it present at the top right corner or the left corner, and etc. etc. So can I get a thumbs up if you guys have understood this basic understanding between image classification and object localization? Because it's a fundamental reason why we need YOLO and how. Okay, thanks. Now let us understand what are the key objects of YOLO. Okay, see the image the image in the left side. The bounding box is there, and you can also see here there is a yellow dot in the middle of the bounding box that contains the dog. This type of bounding box, we actually make this manually. Okay, we have images like in the CNN model. What did we do? We made the data sets, right? We had data sets, but in YOLO we had to make our own data set by our hands. Okay, manual labor. We have to do it. How do we do it? Is that we will learn also. But what happens in the back end when we make the bounding box? It is used in various types of software. The bounding boxes are made in various types of softwares. We will know it later. But when we make this bounding box, the bounding box, what does it do? It breaks that into vectors. It breaks that into vectors. Okay. What does the vectors contains? PC, BX, BY, BW, BH, BH, C1 and C2. What does those full form? What does this full form depict? PC means person. That is there any class or not? Okay. What does PC? That see the image in the left side, the image of the dog. There is any class present. So we return 1. Here it is 1. See the image in the top right corner. There is a person present. So there is availability of class in this image. Okay. So we are throwing a value of PC 1. See. But in the image in the image of the landscape, right at the left of the image, it has no person or class which we want to depict. Okay, which we want to that there is no person or any class or any dog. So we return a value 0. Now what does BX represent? BX represent the coordinates of the center. The coordinates of the center of the bounding box or the centroid of the bounding box. Okay, where it is present. Let's say 50, 50, 70, X and Y. And W and H are the width and the height of the bounding box. Okay, 70 and 60 and 70. And C1 and C2 are the classes. Okay, which class? It depicts which class is present. See here. Here the dog is just present, so it will throw 1, and here the person is not present, so it will throw 0. And in the image in the top right corner, see the person is present. So for class C2, we have taken C2 as person class and C1 as dog class. For the person C2, we depict here. For the person has 1, but C1, which is actually the dog class, it is represented as 0. So for the same goes for this image in the landscape. Have you guys understood this topic? Because please give me a thumbs up if you guys have got. Good. Let's proceed to the next slide. Now see, this the images, right? The three images we have taken. The three images are taken in X train and the vectors are taken in the Y train. मतलब X train को X है input और Y है output, ठीक है? और उसको हम लोग ने लेके एक कन्वोल्यूशनल न्यूरल नेटवर्क, जो कि हम लोग ने पिछले क्लास नहीं, फर्स्ट डे में CNN पढ़ाया गया था, उसमें हम लोग ने समझा था CNN कैसे काम करता है. तो हम लोगों ने डेटा को ऐसे तरीके से हमने ब्रेक किया एंड देन वी फीड दैट total thing into a convolutional neural network. And what did he throw as an output? He throws output as in the form of vector. Okay. So let us show how the prediction is shown. Okay. See this slide. It will make your concept more and more clear. See, when we want to predict an image, the image of the dog. See, the image of the dog is put inside a convolutional neural network. It is already trained on some weights and bias and all. Okay, it predicts all the data and all, and throws out a vector according to it. This vector, and by reading that vector, a bounding box is being made under that of that image. This is how the YOLO works. I think till now, I think it is okay. Please give me. Please react, guys, if you guys have got what I have made you understand. Guys, please react. Thank you. Let's proceed to a more interesting part. Okay. But what if there are more than one object? Till now we have gone through images of more than one object. Okay. What if there are more than one objects? Because there lies a difference between normal basic CNN model and YOLO. Because CNN also does CNN can also do detection, but it will fail to detect objects with images with more than one object, right? That is the difference between YOLO and CNN. Why do we use YOLO? So there lies a difference. Okay. For what we do in YOLO, for that cases, what we do is that we divide the image into different boxes. Okay. Here I am taking 4x4, but it does not mean that for each and every case we have to take 4x4. Sometimes it can take 3x3. So you can also take 5x5. But it depends on whatever. It depends on your classes. But let us understand the main concept behind it. And each and every boxes are taken into consideration. Okay. Let's see the box in the left top corner. Here the box is taken. This box does not has the sense. Look, see this box carefully. This box has the center of the main images, like of the classes of the persons? No, right? So the vector of this class of this box will be depicted as this. Same ways, this same box will be taken. This box will be taken. Corresponding boxes will be taken. Now let us take this box. Okay. When we go to this box has a person class. Okay. It is 0. It is 1. Now same person. Now the BX, BY, and DZ will be taken out of the box. And same goes. But look at one. See the one thing. Okay. Inside this, the object in this box, the center of the dog is present in this box, but the head of the person is also located, but the center is not located. So we will assume that this box only contains the person of the dog, only contains the dog class. Okay. Now let us see the object. Again, see this box. This box contains the center of the class of the person. So it will contain the center as well as these vectors. Okay. Now let us understand a simple conceptual thing. Okay. Let us take see this cuboidal shape. There are 7 vectors. Okay. 7 vectors are there, and there are 4 by 4 boxes. 4 by 4 boxes. Okay. So 4 into 4, it's 16, and there are 7 vectors in each and every vector, in each and every box. So 4 into 4 into 16, 4 into 4 into 4, 16, and it is also multiplied by the size of the vector, which is here is taken as 7. So it will take a shape as a cuboidal shape. Okay, and this cuboidal shape is now, see, this cuboidal shapes are taken as Y trend. Previously, what we were thinking that only the vectors are taken, but actually later on during the modification of YOLO, there are various versions of YOLO. Okay, till now in OpenCV actually there are you can up to use YOLO V11, and it means that there are 11 versions of that has been released till now. जो पुराने मॉडल थे उसमें बस वाई ट्रेन को, जैसे यहाँ पे बस वाई ट्रेन को यूज किया जाता था, जस्ट वेक्टर्स, बट रिसेंटली जो मॉडल्स आए हुए हैं उनमें वाई ट्रेन को एज अ क्यूबॉइडल शेप हिसाब से यूज किया जाता है, एंड दैट इज टेकन एज वेक्टर, एंड दैट इज टेकन एज वाई ट्रेन, दैट इज टेकन इनटू द कन्वोल्यूशनल न्यूरल नेटवर्क. Now let us see the prediction. यहाँ तक अगर समझ गए हो तो रिएक्ट कर दो. Guys, should I proceed further, guys? Please show a thumbs up if you. Okay. Let me proceed further. So now, what comes the prediction part? In the prediction part, also the same image is taken. It is taken into a trained convolutional neural which contains the bias, weights, and all, and it throws the 16 such vectors into a cuboidal shape. And by reading the YOLO itself, it reads the prediction, and it throws out into this format. Okay. Now there is an interesting topic. Okay. Okay. Now there's an interesting topic: intersection over union. Now remember one thing: this is an ML model, or more precisely a deep learning model. So obviously it is not that great efficient. Maybe it can find number of output bounding boxes. Okay, like this in this image we have seen. This has the 0.65, 0.9, 0.7, 0.81. These are confidence. Okay, how much confidence it is showing that the image is actually a dog's image, or a specific person's image or not. But obviously these ML models are not greatly efficient. Maybe it can find number of output bounding boxes regarding that. But कौन से इनमें से कौन सा सही होगा, प्रॉब्लम ये है. तो उस टाइम एक कॉन्सेप्ट होता है इंटरसेक्शन ओवर यूनियन. ओके, इंटरसेक्शन ओवर यूनियन मीन्स, like, what does it mean? Okay, it means that, see, there are two classes. Okay, this white box you can see, and this yellow box over here. Sometimes these types of boxes, when this type of box overlap each other, no, what do we take is that the intersecting area, this area you can see it. I think this area, I think you guys can see it. Okay, this area is taken as the intersection area, and this area is shown by the actual output bounding box. Okay, so this is the main concept behind the YOLO. Now it is done. अभी तक अगर आप लोगों को कोई डाउट वगैरह हो इनमें से कोई भी स्लाइड्स में, या फिर आपको कुछ और पूछना है, you can ask in the chat box or unmute yourself. Feel free to ask any question regarding this. So guys, can you see the screen right now? Please show the thumbs up. Okay, thanks. So अभी तक हम लोगों ने YOLO का theoretical part देखा है. Okay. Now we will go through the actual how the bounding boxes are really made. Okay. तो एक obviously हम लोग चाहे तो manually अपने system में bounding box बना सकते हैं. But there lies a difference between that. Okay. But what is the problem is किसी के पास एचपी का है, जो भी है, सबका कंप्यूटेशनल पावर सेम नहीं है. और जब आप बाउंडिंग बॉक्स बनाते हो तो उसमें कंप्यूटेशनल पावर का बहुत ज्यादा मतलब मीनिंग है. ठीक है, उसका बहुत ज्यादा इंपॉर्टेंस है. तो फॉर दैट वेरी रीजन वी आर यूजिंग एन ऑनलाइन बाउंडिंग ऑनलाइन कंपाइलर ही बोल सकते हो. सो मेरे साथ आप लोग टाइप कर सकते हो. एक ऑनलाइन वेबसाइट है रोबोफ्लो नाम का. सो यू गो टू देयर and let me show you how you guys can make mounting boxes in RoboFlow. मेरा ऑलरेडी साइन इन किया हुआ है, बट तुम आप लोग साइन इन कर सकते हो. वेट फॉर 2 minutes. तो लेट मी मेक सी ऐसा एक इंटरफेस आता है रोबोफ्लो का. तो यहाँ पे आप एक नए प्रोजेक्ट के लिए टाइप करो हेलमेट डिटेक्शन डेटा सेट. ओके, और डेटा सेट फॉर YOLO. Okay. There are 2 classes we will make. In annotation group, we will make actually put the number of classes, which type of class we want actually. One is helmet. The first we want to detect what helmet, no helmet pehn rahe, या फिर no helmet. Okay. Now yeah, we have made the interface. So एक्चुअली में होता है क्या, हम लोग ऑनलाइन से इमेजेस को अपलोड करते हैं एंड ऑनलाइन से लेके इमेजेस को अपलोड करके उससे बाउंडिंग बॉक्स बनाते हैं. बट लेट मी शो यू हाउ वी कैन डू. तो यहाँ पे क्या है, मैं गूगल में जाके सर्च करूंगा हाउ टू हेलमेट people wearing helmet. Okay. People wearing helmet and helmet in public. Okay. Right. तो यहाँ पे सिलेक्ट किया हम लोग ने. फिर इमेजेस में क्या है, सी here's a guy right taking wearing helmet. Okay. इसमें आगे हम लोग सेव इमेजेस ऐड किया. मेरा ऑलरेडी बनाया हुआ एक फोल्डर रॉ डेटा सेट्स के अंदर. आप ये इमेज को ले लीजिए, आप इस इमेज को ले लीजिए, सेव इमेज ऐड कीजिए. ऐसे आप ढूंढते ढूंढते बहुत सारे इमेजेस आपको मिलेंगे. मैं तो 2 ले रहा हूँ अभी के लिए, ऑलरेडी मेरे पास है बहुत सारे इमेजेस. ओके, एंड आपने जो फोल्डर बनाया है आप उस फोल्डर को सिलेक्ट कर लीजिए. ठीक है, जैसे मेरे पास ऑलरेडी एक फोल्डर बनाया हुआ था तो मैंने उस फोल्डर को अपलोड कर दिया. आई एम अपलोडिंग द फोल्डर नाउ. राइट, सेव एंड कंटिन्यू पार्ट. You should upload all the images. Okay. So see, RoFlow एक ऐसा है कि देखो, आप चाहो तो ऑटो लेवल भी कर सकते हो, बट वो पेड है, उसको ना करो तो ज्यादा बेटर है. आप RoFlow स्टार्ट खुद से मैनुअली RoFlow से लेवल करवा सकते हो, या फिर अपने दोस्तों को भी बुला सकते हो इसमें, क्योंकि यहाँ पे कौन सा फीचर है कि आप चाहो तो उसमें दोस्तों को बुला सकते हो एंड देन यू कैन do the labeling, but here I will do start manual labeling. Okay. See here even me by teammates, but assign to myself I will do. Okay. See, I will take this image. Start already. See this image here. Okay. Now I am selecting this part of this image. ये क्या helmet पहना है तो मैं क्या बोलूँगा helmet. Save and enter. Now second image. See this image, this part is helmet. So this I will write it helmet. Save and enter. Sorry, my bad. See. Now, so this part is helmet. See the next part. In this, we have also this as helmet. We have also this as helmet. Also this as helmet. Okay. See in this two image, the lady right in the left side has no helmet. So what we will do? We will take it and write it that she has no helmet. No helmet. Enter. And this the lady in the right side, she has a helmet. She's wearing a helmet. So we will write it helmet. Say enter. This also goes for this helmet. Say enter. Then get this part because it's a manual labor. Manually, we have to do it manually. So you can't do anything regarding this part. So in this part, helmet, and we are almost done with this. Okay, helmet, done. Okay. Helmet, done. Okay. See, we have annotated all the images. So let us add all the 9 images to the present. Right, and upload data and done. See, all the images are taken. But the problem lies in this because as we have time constraints, we have only made 9 images. Okay, but in like do you remember the CNN part? How many images we need? Simple CNN model. Can you just tell me in the chat box? Please tell me in the chat box how many images do we needed in CNN approx, if anybody has any idea. Does anybody know? Okay, I might answer this. For a CNN model, for a basic CNN model, we almost need 4,000 images. Or this is minimum. 4,000 images is minimum for having an accuracy of like 70-80% accuracy. 70-80% accuracy के लिए बस आपको 4,000 images बस चाहिए, मतलब minimum चाहिए. But and we can go beyond that. जितने सारे models होंगे, जितने सारे images होंगे उतना अच्छा होगा. But here we can see that there is only कितने images है बस 9. So बस मैंने आपको सिखाया कि आप कैसे कर सकते हो, images बना सकते हो. आप चाहो तो सेम रो फ्लो में आप खुद के दोस्तों को असाइन करके या फिर सेम टाइप से गूगल से छोटे मोटे इमेजेस लेके उसको बाउंडिंग बॉक्स बना के आप चाहो तो बना सकते हो, राइट? सो this is how you make the bounding box here. And we are done with this. Now let's move to the coding. So let's move to the coding part. Can you guys see the screen? Please react if you can see the screen. Please react, guys. Okay, nice. Now let us understand the coding part. Okay, so the so see in the PIP alternatives part. Okay, the PIP alternative. What is alternatives? Alternatives is the company which made the YOLO model. Okay, so in the step one we will write this changing for installing the alternative software. To install the alternative software, and also remember that there in the collab notebook we have the GPU, right? And GPUs are more powerful than CPUs. So during taking a deep learning model, you are always advised to use a GPU. Okay, so you will use the GPU while changing the runtime. And I'm showing this in VS Code, but this the same thing can be shown in can be done in collabs and very easily. Okay, let us now see the next part. From alternatives, we will check that we will write this command import alternatives and alternatives or checks. We'll see whether all the alternatives packages are installed or not. Now this alternatives from alternatives we will import the model YOLO V11 version 11, and from iDisplay we will import image. Why do we need this command? Because of when we need to display the images from the files. For this reason, we need this command. Now this is the command of from RoboFlow. From RoboFlow website, we need there are thousands of data sets of having helmet. To go there, search and it is an completely open source platform. Take any of those and paste the link of the API key, and you will get the mod. You can download the model easily. Now take the dataset location as well as change the YAML file in that, and make this task, run this command YOLO task is detect. YOLO model is used in various types of tasks, okay, such as in this we need object detection. We can also do tracking and many more models. But in this we need to detect, and with what we'll do mode is train, because we'll do training on a custom dataset model. We have made the dataset and file dataset dot location. Dataset is nothing but this dataset and model is YOLO and PT, because it is a YOLO name, and for how many number of people you want to run the model, and the image size. Now after the model is done, we need to take the okay. Detect and model of predict. For now, we have to predict. What do we need to do? We need to do the prediction part. Okay. And model is equal to where the model's best weights are present. We put that path in there and configuration and choose and put the source where the images are present. After the data is done, model of predict, and the same goes for this is how we test the test data, and in this we test any of the helmet testing, if you want to test any model like any type of video. So for that reason we need to first upload the video inside the drive, and after the drive has been uploaded, we need to in the source we need to upload the path of the source path, okay, path of the video. After that the code is done. Okay, let me show you an example of how, well, we will show how the examples of the codes are done, how the output looks like in, and we will send you the link of this video soon up, as well as the code, as well as the overflow data sets, and all each and every part will be shown as soon as your meeting ends. Thank you for this, and now So guys, you guys can see here is that it is actually a video where you can see how it is detecting helmets and not. See this video. This is an SB. It is an ad of SBI, I guess, and of wearing helmet. See, see in this part. See in this part. See in this part. It can efficiently detect where the helmet is. 0.7 no helmet and which person has not the helmet. And this is the only thing that I was showing you guys, that this is the point where it lies the difference between CNN and YOLO. In CNN, we have, it can't detect, it will detect that it will have no helmet and helmet, but it will not show which person has the helmet, which person does not have the helmet. So this makes this gives an YOLO an upper edge for where real time surveillance is needed. So let us see the whole video first and see this. Uh, See helmet. Uh, the video is actually done. Thank you for your, thank you guys. From after this, the Divya Ranjan will show the quiz for YOLO. Please, thank you guys for your support and present or so guys, just wait a minute.
So the first question is actually from CNN. So we'll ask which layer in a CNN is responsible for combining local features into a higher level feature. Option A, convolutional layer. Option B, pooling layer. Option C, fully connected layer. Option D, input layer. So guys, please try to answer. This was taught to you yesterday in yesterday's session. So if you guys have attended, you may know the answer. So please type in the chat box to know the answer. Guys, with enthusiasm, please try to answer. This is a conceptual question only, and this is a MCQ. At least try. If you don't know the answer, try. Primitive features and combines them to form higher level features, which are then fed to the fully connected layer. So actually, here the answer will be fully connected layer. But good try, Rupati. Good try. At least you participated. I feel good knowing that. What is the purpose of dividing an image into a grid in YOLO? So guys, please raise your hand. Please. And if you want, you can also type in chat, but please try to raise your hand and actively participate. Any responses, guys? Please do fast. Okay, I can see no responses. Okay, so we'll be moving on. The answer was actually the grid allows each cell to focus on detecting objects within its area, which helps locate objects across image. So moving on to the next question. What does intersection over union measure? So guys, please try to answer. If not, this will be our last question of the session. So please participate. Please raise your hand.
Guys, will I get any answers? You can try because it has been taught to you just now. So I guess there's no answer. So I'll be just showing you the correct answer. So IOU basically measures the overlap between predicted bounding box and the actual object, indicating the detection accuracy. So that was it for today, guys, and the workshop. Hopefully we were able to teach you something and light a little spark about machine learning in all of you. And we really encourage all of you to please carry this spark and take forward machine learning and build some models on your own. And if you face any doubts, any problems in and whenever you're doing anything, you can just message us or ask us your doubts in the WhatsApp group or anywhere. So thank you guys, and thanks for joining, and we hope you learned something. Thank you.